All right, so I think we're just about on time to start today's session. So welcome to everyone who is joining today's session, which is on the Introduction to Microsoft Azure Machine Learning Studio and Services. Today's session is led by Ali Paranda, who is a Chartered Engineer and Microsoft Certified Data Scientist. Today's session will be recorded and the recording will be going onto the Microsoft Reactor YouTube channel within about 48 hours. So you are able to access it after the session. Q&A is available during today's session as well, so we do welcome all questions about the content to please ask them throughout, and they will all get answered by the end of the session. So without further ado, Ali, I will let you take over and get started.
All right. Thank you very much, Emma, for introductions. Welcome everyone to this session. Can everyone see the screen? Welcome to this session on
I don't
Azure
think it's sharing just yet.
Yeah,
here we go.
Should be able to see it now. All right, perfect. Welcome everyone to this session on Microsoft Azure Machine Learning Service. I hope you can actually use this session forward to be able to use it to deploy your own models and perform machine learning on the cloud in an enterprise environment. What we're going to do today is we're going to give you an overview of what is machine learning and how you can use it going forward with your own data and how it can be useful. So in the first part of the session, we're just going to introduce you to some of the machine learning concepts just at a high level. And then what we're going to do afterwards, we're going to become more practical and we're going to try to train some models on the cloud ourselves using the Azure Machine Learning Service. Now, in order to follow up with the workshop, you will need to have an active Azure subscription and an active account on Azure Platform Studio. However, if you don't, I will provide you with an alternative so that you can follow along to some extent at the same time. So without further ado, my name is Ali Paranda. So I work for a company called Hack Partners. We produce computer vision and tech products for the rail industry, and we use different types of cloud platforms. Azure is one of them. And in today's session, I wanted to just introduce you to the product itself. Due to the limited time we have, which is just about an hour, we will not be able to go into much detail, but you should be able to understand as a whole what you can achieve with the product and what is the capabilities of the product, so you can take it forward and study and practice it on your own. Even if you want to get certified with Microsoft as well, and you want to get your own certification as a data scientist, this workshop will be able to give you the pathways to be able to achieve that. And it's just basically the same pathway I took in order for myself to get to this point. So for some of you that just joined, like this field is such a big, massive field. Like you can just look at the slide. This is just a slide that a venture capital firm called Firstmark put together of all the various technologies that are in this field of AI. And it's just like so many technologies and so many different companies working on different bits. And it just can be very overwhelming for someone who just started working in the industry and in the field. The good news is you don't need to know all of these technologies. You just need to know a few of them, and you can always specialize in those bits that you enjoy the most. So you don't have to go and try to learn everything, just the bits that you have to learn. The most important points that you need to understand is that machine learning is kind of different from traditional programming in a sense that with traditional programming, you write your conditional statements, you write your loops, and you write a specific set of instructions for a computer to perform a specific task, such as calculating some aggregations or doing some data analysis and so on. And this is usually very useful when you have a very specific pattern and that you want the computer to follow a specific set of instructions you want the computer to follow, and then the computer does that exactly as you intend. With machine learning, this is a bit different in the fact that you don't write specific instructions for the computer. You use algorithms and the data to produce models called machine learning or AI models, which then these models learn patterns from the data using those algorithms so that they can adapt to constantly changing environments. So let's say, to give you an example, let's say you want to write a program that would detect spams in an email. So these are very specific examples in machine learning. If you want to write a traditional program, in a sense, to just basically, if there are some words in an email, flag them as spam, the spammers can get away around that by figuring out the way you've written the program and then just changing the emails in such a way that they can get around your exactly written conditions. With machine learning, this is not the case. What machine learning does is that it goes through all of the text in those emails that have been labeled as spam or not spam, and then it figures out by itself, using the patterns it finds in the data that you don't teach it, it learns by itself, which one of those emails will be spam and will not. And that model is what the algorithm produces. And you can then use this model as like a function. So like in programming, you write a function. In machine learning, you can then use that model to just make predictions to certain confidence levels if a specific email is a spam or not spam. So this is just like an example to showcase what the technology can do. And with the current advancements in cloud technology, like with products such as machine learning service, you would be able to do this to train your own models now using your own data, so that you can automate tasks or predict the future in such a way that you cannot do by writing conditional programs in such a way. You don't need to write, decision trees or anything like that yourself. The computer can now make its own decision trees, and it can figure out its own program just by giving it data and using a certain algorithm to produce those models. It's even expanding to such an extent now that it's becoming a norm. The government, as you can see, some of the applications that machine learning and AI has been used, and I just basically took this slide from the government website on like what are the different types of applications people have used. Like a signaling company used AI to help trains run on time. Natural language processing to structured market research, and just like so many different applications going forward these days. And it's becoming more and more the norm to use AI going forward. And there are even like guidelines in place, and so it's getting to such an extent that there are guidelines in place and frameworks that you can follow, and all available on their government website if you're interested in reading more about these. Before we go into the workshop itself, I just want to give a bit of an introduction of various types of AI and machine learning we have. Basically, when we're talking about machine learning, it's a subset of artificial intelligence. So AI is built up itself, and machine learning is just a subset of AI where we basically use statistical algorithms to develop models that would then be used to predict or to automate tasks. And so when we were talking about machine learning, in a sense, we're just focusing on one subset of AI. AI by itself is a big field. It encompasses all sorts of different topics, which you can see on the right-hand side of this image. And one subset of machine learning is deep learning, which we will not cover today, which basically encompasses neural network programming and more advanced applications of machine learning, where you have to build architectures of neural networks and use those specific type of algorithms to build models. And those models are usually more advanced, and they can process more advanced data, such as images and videos, to do more complex things. So for this workshop, we will just focus on machine learning using normal data sets, such as a credit history data set or weather data set and so on, to make some models on top. Machine learning itself is divided into two subcategories. One is supervised learning, and one is called unsupervised learning. So when we're talking about supervised learning, our data is labeled. So imagine the spam problem, if detecting which emails are spam, which are not spam. The ones that are spam, we have labeled them as spam, and the ones that are not spam, we have labeled them as not spam. And then basically the model uses these labels and the data itself to figure out patterns, and then figures out which of those patterns relate to the spam and which of those patterns relate not to the not spam. With unsupervised learning, imagine the data set not have any labels, and then the model tries to figure out the structure by its own. And usually we use that to cluster different types of emails together based on the patterns you see in them, and associate them together using those patterns. So the main difference is, if you have labels, you have a supervised learning problem, and if you don't have labels, you have an unsupervised learning problem. And use the correct algorithms based on the problem you have. Again, these types of machine learning can break down into further, more refined areas. As you can see here, you could have even semi-supervised learning or reinforcement learning, which are two other areas that we're not going to today. Today, we may just focus on the supervised learning, in particular classification, an example, where we, for example, try to detect, where we have a labeled data set and when we're trying to classify rows of data into two different categories, like binary categories. So for example, in a credit risk history data set, we're going to classify whether a customer is high risk or low risk if you want to give them credits when they make a credit application. In a regression problem, we will predict, for example, where, for example, the price of a car would be or price of taxi fares would be based on different features of that taxi ride or different features of that car. This is how a supervised and unsupervised learning problems could break down into their different applications, as you can see on the platform, on the slide. To make it a bit more, to just focus a bit more on this, let's focus on supervised learning. This example where you have, let's say, of labeled data. Here we have set of labeled images that are called cats. The model, when we build the model using machine learning, the model then uses these labels to understand what are the patterns that relate to cats and what are the patterns that relate to dogs, and then it can then distinguish between them. This is a supervised machine learning problem, and the two biggest types of machine learning problems that are supervised are called classification and regression. So in a classification sense, if you have your data set plotted on an XY axis like this one, in classification, you're trying to fit a line in a way that your data points are separated in two different categories very cleanly, in a clear manner. Now, depending on complexity you have in your data set, it may not be a straight line, it may be a non-linear line, or you may have so many dimensions in your data that you may not have an XY axis, you may have an X, Y, Z, J, V, W. You have a multi-dimensional grid where you're trying to fit hyperplane in this field, in this 3D and ND space in such a way that would separate your data points. And in classification machine learning, what it does is that it fits this hyperplane in such a way that it can separate these data points in all of these different dimensions. And that's where the power of machine learning comes in, where it can identify these patterns in the data. In regression, you're trying to fit a line through the data points. So in an n-dimensional space, you're trying to fit a hyperplane in such a way that all of these data points lie on the hyperplane as much as possible. And machine learning figures out how to do this using the algorithms that are out there. For example, regression algorithm, and so on. Two examples of these problems in regression classification. Regression is what is the temperature going to be tomorrow? You based on historical data. So the model will give you a prediction in terms of the value itself. But in classification, we're just interested in knowing if it's going to be hot or if it's going to be cold. And depending on what kind of model to train, we can get outputs from the model. So model are going to be regression, or it's either going to be classification. The data that you will need to give to the model to make your model specialize in one of these two problems is if you're going to do a regression problem, the data needs to be continuous variable. And if it's going to be a classification problem, the data is going to have to be categorical to some extent. In terms of unsupervised machine learning, again, your data set doesn't have labels, so you just have a bunch of images, and then the algorithm itself trains a model that then the model basically tries to figure out by itself if cats have similar features and if dogs have similar features and groups them together in that way. Two problems that are usually very mostly used to applications of this kind of unsupervised learning is clustering and anomaly detection. So clustering is basically, for example, if you have a data set of like flowers, and if you plot them on XY axis, you want to understand based on just these data points, what are the clusters of different flowers on this data set. And the model will try to learn these patterns by itself and groups these different data points together. So usually clustering is used, for example, in segmenting customers for a business, or for example, if you watch YouTube videos or you watch Netflix, Netflix and YouTube will try to cluster you in different types of viewers based on your viewing patterns, so that then they can recommend you the correct type of videos that you would be most interested in. So that's where clustering machine learning algorithms come into play. With anomaly detection, it's more about understanding, basically learning the patterns in common format. So the normal it happens in data, and when something like if there are any outliers in the data, or if there's some events happening that are basically outside of the norm, because the model has learned the norm in the data, it can then flag out outliers for you. So this is where anomaly detection comes in. Usually they're used in fraud detection applications where there are like certain transactions happening that are usually outside of the norm, and then a machine learning model can then detect those transactions as being fraudulent. So this is where it's going to be mostly useful. So for today's exercise, what we're going to try to do is we're going to try to build either a regression or classification model based on the data that we have access to on Azure Machine Learning Service. If you don't have active Azure Machine Learning subscription, so to have access to this page where you can, this is the Azure Machine Learning platform, the portal, Azure portal, where you can instantiate resources, you need to have an active subscription. If you don't, you can go to studio.azureml.net. I will just post this for you in the chat, so you can basically go there and sign in. You only need just a Microsoft account to go sign in here. You don't need to have any type of you don't need to sign up a credit card or anything like that. But for the Azure Machine Learning service itself, you will need to have a credit card, and you will need to have an Azure Machine Learning subscription. So to follow up with the workshop, you may incur some charges. It's not a lot, maybe about £5 or so. If you don't want to do that, you feel free to use the Azure Machine Learning Studio, which is more like a simplified version of the Azure Machine Learning service. So this is just this is an educational tool. If you use Azure Machine Learning Service, this is an enterprise tool, which we can then scale. And I will talk about the differences between them when we start the practical side of the workshop. So what this tool allows us to do is it comes with its own visual designer tool. So you don't need to have any coding background if you want to do machine learning on the cloud. You can use this designer tool to drag and drop blobs around and connect them together. And then we press run, and then the data flows through these blobs, and then it trains a model, and then you can then deploy that model onto the cloud to use it as an endpoint for doing your predictions. So you use an algorithm, you train a model, you give your data, you clean your data, all within this workflow, within this pipeline that you build on the right-hand side. So this is what the Azure Ml Studio looks like. So this is the educational tool that I just showed. If you don't want to use the active subscription on Azure, you can use this tool. You can still follow along, but the interface might look a bit different when we go into the Azure Machine Learning Service, which is the enterprise tool. But they all look similar in terms of like the functionalities and how you connect blobs and how you drag and drop blobs around. The platform also allows you to visualize data like the one you see here, and it allows you to see like relationships between different columns and the distribution of data points within these columns, which is very useful if you want to just do a quick analysis to see if your data is balanced or unbalanced and which features are the most useful ones for training your model. So the model learns the patterns in the data. So if you select one of these columns to train a model on, and that specific column needs to have a relationships with other columns in order for a model to effectively learn those patterns. If there are no relationships and correlations, the model that you train will just basically be very random. It doesn't learn any of those patterns because none exist. And this is basically one point that we will go to when we dive a bit deeper into this platform. And with Azure Machine Learning Studio, you can actually grab an Excel file at the end that you can basically send your data to when you deploy this model, and then you can get your predictions back. Azure Machine Learning Service itself doesn't include this. This is just for the studio. So the main differences is studio is educational and it's just basically for learning. Service, when we're talking about Azure Machine Learning Service, that is the full-on platform that you can do proper machine learning on the cloud. So without further ado, go forward. Feel free to post your questions in the questions box in the Q&A section, and I can answer them within the next few minutes. And after that, we will just jump in straight to the practical side of the workshop. What you will need is you will need a Microsoft account. If you don't want to spend any money, use the Azure Machine Learning Studio Classic, which is here. You can access that studio at azureml.net. Otherwise, jump into Azure portal, which is Microsoft Azure. Just log into your portal and you should be greeted with this screen, which then we will instantiate Azure Machine Learning Workspace and go from there. And we will show you both of these so you can get a sense between both of them and how they differ. So we'll just wait a minute or two for people to just get set up and sign into the accounts. And if you have any questions, feel free to post them in the question box.
So, Ali, I think just a question came through there towards the beginning. Roy asked if the presentation is going to be made available after the meeting. So I'm not sure, are you able to share this slide deck or this presentation afterwards?
So I will, because of the time, there's so much content in here and I will not be able to go through it all, but they are very useful content. I will be able to share this with you so you can study it on your own. There's some stuff about how to split data, like different metrics and things like that. I will not cover this today because of the time, but I will recommend you to go through this and try to basically experiment yourself with the designer tool so that you can learn a bit more about machine learning and everything else. So yeah, I will share this slide with you at the end.
Brilliant. And I think just two more questions came through there in the Q&A. So a question came through, could you clarify what the enterprise service version has that the studio does not? It wasn't clear from the explanation.
Sure, definitely. So the studio is this is the studio and this is the enterprise version. The studio version is just a drag and drop tool. And it's limited in terms of what you can do in terms of running production level machine learning models on it. You cannot train production level machine learning models. And when you upload your data to do machine learning on it, your data will be publicly available. So it's not a private workspace. It's just a workspace that you go into and you have some public data sets in it that you can play around with those. And when you deploy your model, it deploys an endpoint for you. But you cannot use that endpoint as a production level grade endpoint where it's always reliable and so on. So it's just for learning and it only uses CPUs. You cannot attach a compute instance where you have GPUs and you can train a model on the GPU. So you cannot do hardcore like professional level machine learning on it. It's just for learning to work with the tool itself. But the good point is that it's free. You don't need to have any credit cards, nothing, and you can sign in with just a normal Microsoft account. The workspace, you will need an active subscription, and in order to have access to the ML Designer tool, where it's a more of a revamped version of Studio, you will need to have a credit card, and you need to also instantiate an enterprise level workspace, where all the pricing is sorted. For today's workshop, it's not going to cost more than £5. Everything we're going to do, because we're not going to do any hardcore stuff on it. But you can build production grade models, deploy them, monitor them, retrain them, and basically use the service in such a way that can be used in your real world projects. And it also integrates nicely with rest of the Microsoft Azure ecosystem. So if you want, you put your data in a storage, cloud storage, and use, which is basically account storage, and then use your data from there and pull them, and then like connect up SQL databases and stuff. You can do that within the Azure platform. One other thing that Microsoft Azure Machine Learning Service has that Studio does not is that the machine learning service has a feature called AutoML, which is basically AI training AI models. So think of it as one part of the workflow when you train machine learning models is playing around with the hyperparameters on the machine learning algorithms to see which one is the best one, which algorithms are the best algorithms, and which hyperparameters are the best one to get the best model with the best accuracy. Machine learning service Workspace provides you with such a feature that you can basically train models with various types of algorithms and various types of hyperparameters and choose the best one that matches the patterns in your data. You don't get that in Studio.
Brilliant, thank you. A few more questions have come through. Do we have time for them now, or do you want to carry on and come back to them?
I can answer one more question before we start.
Sure. So one is about, will I be warned if I'm going to incur any costs if I use the Azure ML? I think you might have touched on that.
It's not that much. It's less than £5 because basically 1 hour of instance when we use is just less than, I think less than 10p or 20p. But if you're very worried that you're going to incur like costs and you don't want to do that, just feel free to just watch the video and use the Azure Ml Studio instead of Azure ML service. But then again, I assure you that it's less than £5. You just have to make sure when we create this workspace at the end of the workshop to delete the workspace. Otherwise, you may incur more charges if you leave like compute instances running and you don't shut them down and so on.
Brilliant, thanks for that.
Thank you. All right, so without further ado, for those of you who want to use the free service, just sign into Azure ML Studio. For those of you who want to use the Azure Machine Learning Service, you can basically see the icon here, click on that, or just search Azure Machine Learning on the top bar here, and it should come up here. And when you click on that, you can instantiate it. You can create an Azure Machine Learning workspace. So when you click on that, there are some fields that you will need to fill. There are not many. You will need to have a resource group. If you don't have it like I do, just create one. So resource groups are just basically containers to group your resources together. You can name it anything. I'm going to call it ML Workshop. And give it a workspace name, anything you like. I'm going to call it ML Workspace. Put it in the region that's closest to you. I'm going to put mine at West Europe because I'm in London. And then for edition, click Enterprise because the basic edition does not the designer tool, which is the drag and drop blobs, as well as AutoML. So if you want to get some practice with AutoML, click on the Enterprise and then create, review, and create. So if everything works correctly, a validation will pass and then press create. It will take about 2 to 3 minutes to deploy your workspace, and then you can then log in into your workspace. So you can monitor the deployment here, and then when it's done, you should get a button that you can click on, and then it will take you to the workspace. If you're going to use Azure ML Studio, you should be greeted with such an interface. Just click on experiments. So you can see I've already got some experiments going on here. There are some buttons at the bottom. They're kind of hidden. So there is a new button. If you click on that, it will open up a menu where you have a bunch of tutorials and a bunch of already made examples and exercises that you can click on. For this workshop, I think the one that we want to work on is the classification example, which should be, let me just see, the binary classification credit risk prediction. So if you open this one up, it will open you up with a ready-made workflow pipeline that you can play around with. Which if I just move my cursor, because I think I opened it in the wrong side, this is what it looks like. And then I will show you the same exact example in Azure Machine Learning Service, and then we can play around with it. Then we press run on these, and then we will go and build our own from scratch. So we will try to rebuild this from scratch ourselves. So the resource is ready for Azure Machine Learning Service. So this is what it looks like in Azure Platform if you have created it just now. If you press launch now, it will launch the workspace for you, which looks like this, still in the preview stage. So that means good. You're not going to incur charges for using the service itself because it's still in the preview. So you can see on the interface itself, you have 3 sections menus on the left-hand side. You have the offering sections where you can have Jupyter notebooks to do machine learning if you want to use notebooks to do that. You have automated ML, where you can instantiate experiments and runs to use the AutoML feature that I talked about, where it selects the best algorithm and best hyperparameters for you, given a data set and a problem. You have the designer tool, and this is just basically the studio, but revamped and upgraded for enterprise level, enterprise workspaces. And then here you have the assets. So if I just open this up, you have your assets. So if you want to register any data set or you want to upload any data sets, you can do here. Mostly the best patterns to use is just to upload your data set in a storage account on Azure Platform, and then just register them here so that your machine learning workspace can see that data set and you just work from that. You then also have experiments, pipelines, models, and endpoints. The differences between them is experiments are if you want to experiment with, experiment is just like basically a container around all of your runs and pipelines and workflows. So you create an experiment, it's like a project. Yeah, think of it as a project where you do everything in it, and then the output of that will be your model. Pipelines is basically the pipeline that you build in terms of like how the data set should go through those modules to reach your model at the end. When you have a model that you're happy with, you can register it here and it will show up in this menu, which then you can deploy as an endpoint. And then your endpoints will be shown here with the APIs and everything that you can then use for your application. So if you're building a mobile app, you're building a web app, you can then use these endpoints to send send a request to your model and get predictions back. In order to train models, you will need to use compute instances. So this is where you can create your compute instances and compute clusters. Clusters are useful for training. So if you have a heavy workload, if you have a heavy training job where you will need lots of compute power, like lots of CPUs or GPUs, this is where you will create them. So you can create like a cluster of nodes, workers that will basically run your training on, and train a model. And then you can also have a cluster for basically sending predictions to the model, and then these clusters will run those predictions through the model and then send you back the predictions. And these are what you will use. And then attach is just basically if you have your own compute that you want to attach to this workspace, you can use an attached compute. We will not cover this, but this is something if you want to reduce the costs, instead of using the Azure's compute resource, you can use your own compute resource and attach it here for this workspace. So for this, go to the designer and click on the binary classification. I think, let me just see which one it is. This one, sample 4 is the one that we want to use. So click on that and it should load you an example, which is exactly similar to the example we've seen with some extra bits and bobs. So the examples are using the same data set. It's a German credit card UCI data set. If you want to know more about it, just Google it and it will bring you up the information about the data set. It's just basically, if I try to visualize it for you, I can right click on it and press visualize. And then you can see a data set that looks similar to this. It looks weird because it's just, you will see just a bunch of letters and numbers in it. But basically what each of these columns mean is different fields of an application form. When someone has filled it, for example, if they own a car, if they don't own a car, if they're renting a house or they're a house owner, how much credit in the past have they used, how many times have they been defaulted, stuff like that. And then the last column is the label column. Basically, I think 1 means they're good risk, column 2 means they're bad risk. So if it's 2, it's bad, if it's 1, it's good. So this is the risk of the credit application. And then we can train a model on this column to then predict based on application, based on this credit application, is this customer going to be high risk or low risk if you give them credit? And then what is happening is just basically through these modules, as the data flows through them, we transform and clean the data set. And then we basically put some names on top of the column names so that we understand what we're working with. And then it then goes through all of these rest of the modules that will then train the model. Don't worry about understanding this whole of this pipeline at the moment. So this is called the pipeline with all of these data flowing through these blobs. So think of this as a pipeline. This is a very sophisticated pipeline when it's trying to train multiple models using multiple algorithms to figure out, to compare them together to figure out which one is the best one. Same with here. The reason it's a bit complicated is because the data is flowing through some modules at the top to just get splitted and cleaned up, and then it follows through some scripts and some modules to get normalized, and then goes through these trained modules to then train a model, then score a model. So each of these 4 trained models get scored and then get evaluated, and then at the end, they are summarized in one simple table, so you can compare these modules together. So to understand how this works, let's just run the whole experiment. So if you're on Azure Ml Studio, run this model. This exact same specific example is also in Azure Machine Learning Service. So if you want to run this, you don't have a run, you have a submit button. You need to submit this pipeline as a workflow to a compute instance to run it. So in order to do that, you will need to create a compute target, and then you will need to attach a compute target to this pipeline to then run this pipeline so that your model can be created. So let's do that. So let's select the compute target. And and we don't have anything available at the moment. So what you will need to do is you will need to create your own. You can basically, the workspace itself recommends you to use, based on the pipeline we have, it recommends you to use a 2 CPU, 7 gig RAM, 8 GB storage with 2 workers compute cluster. If you're not happy with this and you want to create a custom one, what you can do is you can go to compute here, and then you can basically create your own, which then you can select either CPU or GPU, and then you can also select all various types of like different categories from here. So you can actually build some really hard, you can actually connect up some really hardcore compute depending on your application. You can see here, you can get like compute clusters with like 64 cores and 1,000 gigabytes of RAM and 2,000 gigabytes disk. And this is just CPU. If you want GPUs, you can select GPU, and then you can select basically what GPUs you want. So NVIDIA, Tesla, and so on. So it's up to you what you want to do depending on your application. For this specific example, what I'm going to do is I'm going to try to just use the recommended example, just because you don't want to incur costs more than you need. All you need to do is just basically give it a compute name. So I'm going to give it training cluster, training workshop cluster. And let me just name it something so it doesn't give. So I'm going to call it training workshop. So this is my training cluster that I can train model on. Press save. And then what it will do, it is now in the background creating my cluster, and it will let me know when it's ready so that then I can submit my job to it so that the pipeline runs through the workflow. Press save. So when it's ready, it will get attached So now it's succeeded. So if I click on it when it's succeeded and press save, I can now see that it is now attached to this pipeline, and then now I can submit my job to it. So in order to run a pipeline, as I said, you will need to create an experiment. Think of it as a project. It's asking me, what is your project name? I don't have a project at the moment. So all I want to do is I'm going to call this experiment basically credit card experiment. Submit. And now the run is started. I should be able to get visual feedback. You can see all of these modules are now tagged start and not start. If I just close the settings and I zoom out a bit, just zoom out, you should be able to see what is happening. You can see the view run overview here and the attributes of the run if you want to see the logs, and you can see in live where the process is at the moment. So at the moment, it's running through the data through this edit metadata where it adds column names to the data set so that then we can work with. When the run is finished, we can then look inside each module to see how the data is changing as the data is flowing through these different modules and blobs. The good thing about this Azure ML Studio platform, as well as the one here, which is now finished, is that you can actually look inside the blobs. You can look inside the blobs itself and see how the data is changed. You can also run and write your own Python script, like the one you see here. So this one is replicating the risk sample 5 times. So if I just open the script, oh, actually, I think this because it's running, I can't. Let's see if the same script is here. I think this one is written in R. So for those of you who know R, all this is doing is grabbing the rows of data that are positive and the rows of data that are negative in terms of like high risk and low risk. And it is replicating those rows that are low risk 5 times. Sorry, high risk 5 times. Just because basically the data set is unbalanced. So it wants to give the model enough chance for it to learn, to see enough instances of bad credit so that it can learn to distinguish between them. Because the data set is unbalanced, we're using Python scripts to just basically, in a very just coarse way, duplicate the bad credit applications or bad credit rows enough time so that the model can see both instances of good applications and bad applications enough time so that it can learn to the same level of sensitivity to distinguish between them. And that's how we can use the data sets like this one. We're using normalized modules here just so that we can normalize the data so that the model can train a bit better. Sometimes your columns might have data continuous variables in them that are all over the place. Some of them might range between 0 to 200, others may range between -200 and 500. So normalization just basically normalizes them between 0 and 1 or -1 and 1 so that then when the model learns, it learns the patterns much easier. So the columns are like in the same kind of range and it learns the patterns much easier. So while this is running, so this may take a while for this one because it needs to instantiate the clusters for us and prepares everything. So on the Azure Machine Learning service, it may take a while for these things to run. But the main reason would be that the data set here is much larger compared to the data set in Azure ML Studio. But while this is running, let me just show you some of the stuff you can do as Azure ML Studio. And you can do the same exactly in machine learning service. So in the studio, you can see you have exactly the same data, but you only have 1,000 rows. When this finishes, I think I can show you, I can't show you now, but I can show you when later on when, oh, actually, let me see if I can visualize it. So you have 1,000 rows here as well. So now it's running through. So here, this is the raw data in its raw format. But if we go and look at the second blob and you click on the output node and visualize the output node, you would be able to see that now the columns have a name. And you can see what each of these columns mean. So one is the status of checking account, duration in months, credit history, purpose of this credit application, how much they're asking for, if they have savings account, present employment status, personal status and sex, basically stuff like that. Housing, job, number of existing credits at the bank, and all of these things. And each of these categories, A192, means something. And you can see on the right-hand side what they mean. If we want to see the relationships between these different columns with the credit risk, we can use this. We can see here that the dataset is already unbalanced. There are 700 instances of 1 and only 2 instances, and only 300 instances of 2. So you can already see there is just not enough instances of this application, and you can check. Basically, you can compare this column with the rest and see the relationship between the target column that we're training on versus the rest of the other columns. And depending on the categories, you have different relationships and different patterns. So all of these columns are different dimensions in the data that our model is training on. As you can see here, each one that I compare this column to look different. The patterns look different for each column, and each category means something. And what the model is doing here is learning these. In this module, we are splitting the data 50-50. So 50% of the data is going to training, and 50% is the test, which goes to the SCAR module straight. So one of the principles in machine learning is when you train a model, you will need to score it and test it. And to test the model, you need to set aside some data for testing and don't show that data at all to the model until it comes to the testing stage. So that is what's happening here. We're sending 50% of the data to training and 50% to testing. You can split it the other way around. You can split it 70% and 30%. Normally 70%. In this example, they're doing it 50%. For training, we're normalizing the data, and then we're using 2 different types of algorithms. Here is called 2-class support vector machine and 2-class boosted decision trees. I think in the Azure ML machine learning service, we're using exact same thing as well. So while these models are run, let's have a look at the output of the split test and see what it looks like. So you see, it's only 500 rows instead of 1,000 rows. So it is now splitted. And if you go down, you can keep looking at the output of each node to see how the data is being normalized. So you see here, this was a continuous variable column, and now it's been normalized between 0 and 1. Previously, it was not between 0 and 1. If you look at the trained model, you should be able to see the various weights and parameters that the model has learned, so that it basically matches the relationship between the credit risk being good or bad to the rest of the columns using these values that it has learned just by looking at the data. So this is still running. It has completed some steps. And then if you look at the score column, so let's just take out one of the models and look at the score of them. You would be able to see here that if you go all the way to the right-hand side, you have 2 more columns. So do you remember previously was 21 columns, now it's 23. We have 2 extra columns called scored labels and scored probabilities. So these are the predictions that the model has done by looking at the applications. So these are, 1 means good and 2 means bad. So it thinks for this specific application, this is a bad credit, so that's a mistake. But you can also see on the right-hand side by scored probabilities how confident it thinks about its prediction. So what you want to see, you want to see a very high number with a correct prediction. And we not necessarily may see that here. In order to understand how it's performing, we need to do an aggregation across these columns to figure out how much is performing and how much is not performing. So if you look at the evaluate module, you would be able to compare results between these 2 different modules that are connected to this blob. And then we use different metrics such as the log graph, accuracy, and precision, recall, and F1 score. So these are like very standard metrics that we use in classification tasks to compare between different models that have been created and algorithms that have been produced. And you can see how many of these predictions are false negative, how many have been false positive, how many have been true positive, and how many have been true negative. And then you can calculate the rest of these metrics, such as accuracy, precision, recall, and F1 score using these metrics. If you want to know more about the ROC graph and these metrics, in my slides, I have provided some information for you. I think at the end of the slides, or I can provide it for you. I'm not sure if I have provided them here, but I can provide them for you in the slides where when I share them around, so you can learn a bit more about that and use that to understand. Basically, in a simplest form, you're looking for a model that has higher, you're looking for an algorithm that has higher space under this ROC graph. That usually is a model that performs better compared to the other models. And if you look at the output here, it's just basically comparing the results of all of these 4 different columns. So here we see a weighted SVM is performing the best compared to the rest of the algorithms, which is the unweighted SVM and unweighted boosted decision tree. Weighted and unweighted is basically about the unbalanced and balanced. So do you remember we duplicated the rows of the data set that have their bad credit, that were kind of unbalanced? Weighted basically means balanced data set. So when we have balanced data set, we have gotten exactly like 20% better accuracy just because the data set is now balanced compared to when we have not weighted it. And SVMs are doing much, much better compared to boosted decision trees, just because of the data set that we have and the patterns that there are in the data set. You will get exactly the same you will be able to get exactly the same results as well when you perform this in Azure Machine Learning Service when it's done finished, and you will be able to go more into detail and deploy this on a more large scale when you get to that. Just because of the time, we would not be able to go into and show you different bits, but in a simplest form, this workspace allows you to perform machine learning without actually having to know coding programming language like Python or R. If you know, it's really good, because then you can write custom scripts like this one that you can see on the right-hand side. Otherwise, you can use this service and you can use the modules on the left-hand side, as you see here, to perform your machine learning itself. There are lots of tutorials available. There is also a Microsoft Learn path if you want to learn more. It's about 8 hours that you can do and practice. It's available at Microsoft Learn. So if you go to the docs.microsoft.com and you go to Learn, search for Build AI Solution with Azure Machine Learning Service. And then there are a bunch of courses here that will teach you everything you need to know about orchestrating, deploying, and tuning hyperparameters and so on that we didn't manage to cover in the workshop today just because of time. With that, I open up the panel to questions. If you have any questions, feel free to ask, and I'll be more than happy to answer them. Thank you.
So Ali, thanks so much for that session. Lots of really great information there, and there's been lots of really good questions come through as well. Would you be happy with me reading them out, or did you want to go into the Q&A yourself and go through them? I'm happy with either.
I think, yeah, if you can read them out, that would be good, but I do have access to Q&A as well.
Okay. Great. So we'll go back a bit. So Shane has asked a question: Is machine learning service for data scientists and Machine Learning Studio aimed at non-data scientists?
So Machine Learning Studio is for beginner data scientists and beginner machine learning engineers who want to just practice with learning the concepts without incurring any like high charges. Workspace is more for professional data scientists and professional machine learning engineers who want to experiment fast without writing lots of code. Like normally you have to go in scikit-learn or other machine learning libraries, write code and to do some experiments. Here you can do experiments very quickly on your own data set and figure out what is the best model and go forward with that. So to answer the question, Workspace, professional, Studio, more educational.
Okay, great. So next question. Could someone from Microsoft please post into the chat 1 to 2 links to customer/developer ready data sheets comparing the Service and Studio versions? Do we have something like that we could share?
Yes, I think there is an article on the docs as well. So if I Google it just now, Azure Studio versus Machine Learning Service, there is a doc that will give you the exact comparisons between them. So I think I just saw it now. Here you go. So that's the doc, and you can see the exact table. You can compare between them. So I'll just post this in the chat for you.
Brilliant. Okay, great. All right, next question. Can you distribute training in Azure ML? What does that process look like?
So when you cluster, when you basically in the, so let me go back to the pipeline. Here, when you use the pipeline, it is using a cluster of compute resources to just distribute the workload for you, so you don't have to worry about the infrastructure setup. You only get to attach a cluster of computers, and then the cluster, the workspace itself figures out how to distribute the workload between the nodes, so that everything is trained up at the same time. And as you can